take down a problem based on equivalent capacitance. The equivalent capacitance of the combination, the equivalent capacitance of the combination between points A and B in the given figure is 4 microfarad. Microfarad. Calculate capacitance of the capacitor C. I will give you the figure. So the questions are: A, calculate capacitance of the capacitor C. B, calculate charge on each capacitor. Calculate charge on each capacitor. If a 12-volt battery is connected across the terminals A and B. If a 12-volt battery is connected across terminals A and B. And the last question, C, what will be the potential drop across each capacitor? Across each capacitor. I'll give you the figure first. So the equivalent capacitance of the combination between points A and B in the figure is 4 microfarad. So the figure is, I'll draw it here. We have two capacitors. Now this is point A, this is point B, so this is C, which we need to find out, and this is given 20 microfarad. The equivalent capacitance of the combination between points A and B in the given figure is 4 microfarad. Calculate capacitance of the capacitor C. First we need to find out what is C. So I'll write solution. So as we see from the figure, the two capacitors are connected in series. We know when two capacitors are connected in series, the equivalent capacitance is given by 1 by C equivalent equal to 1 by C1 plus 1 by C2. So this is the case when we have two capacitors C1 and C2 are connected in series. Now let us substitute the given values here. Given the equivalent capacitance is 4 microfarad, so C equivalent is 4 microfarad. given C equivalent as 4 microfarad. Also given C1 is 20 microfarad. And given C2 is C. So we will first find out what is the value of C. Substitute in the given equation and then calculate what is C. The equivalent capacitance C equivalent is C equivalent equal to C1 into that is 20, or I will write like this, so we can directly simplify. The equivalent capacitance is also given by C equivalent as C1 C2 divided by C1 plus C2. So now you substitute these values. C equivalent is 4 microfarad. 4 micro equal to C1, that is 20 micro, into C divided by 20 micro plus C. Simplify this, we will get 20 micro plus C is equal to 20 microfarad plus C is equal to 20 by 4, that is 5. 20 divided by 4 into C. So this is equal to 5C. 5 micro, sorry, this is 4 micro, so micro will get cancelled, so we'll get 4C. 4 micro, so 20, 4 5s are 20, so we'll get 5C. Now 20 micro plus C is equal to 5C. 20 micro plus C is equal to 5C. So simplify this, we'll get 5C minus C, that is 4C. 20 micro equal to 5 minus 1, that is 4C, or C is equal to 20 micro by 4, which is equal to 5 microfarad. So unknown capacitance C is equal to 5 microfarad. So the first question is over. C is 5 microfarad. Now what is the second question? Charge on each capacitor if a 12 volt battery is connected across terminals A and B. So this is if. if a 12 volt battery is connected across terminals A and B. So how do we find the charge? Charge on capacitor Q is C into V. Or the charge on combination is charge on combination. Charge on combination is Q equal to C equivalent into V. C equivalent into V. So Q is equal to, C equivalent is given, that is 4 microfarad. And he says like 12 volt battery is connected. So this will be 4 multiplied by 12, 48 microcoulomb. So since two capacitors are connected in series, same charge 48 microcoulomb lies on both the capacitors. Because capacitors are connected in series, same charge lies on both the capacitors. So charge on each capacitor is equal to 48 microcoulomb. Charge on each capacitor is 48 microcoulomb. Now the last question is, what will be the potential drop across each capacitor? We know the potential drop across each capacitor is given by, so we can use this formula. We know Q is equal to CV. So V is equal to Q by C. So let us use this formula. So first you find out potential drop across 20 microfarad capacitor. Potential drop across 20 microfarad capacitor. Is V1 is equal to Q by C, that is Q is 48 micro by 28 micro. So we know micro will get cancelled. So this is 48 by 20 is 2.4 volts, because 2 4s are 8 and 2 2s are 4, so it will come 2.4 volts. Similarly, potential drop across 5 microfarad. So we have got the C value as 5 microfarad. So this was like 20 divided by 4, 5 microfarad. So we can find out what is the potential drop across 5 microfarad. Right here, potential drop across 5 microfarad. V2 is equal to 48 micro divided by 5 micro. So this one is equal to 9.6 volts. You can add these two and just check, cross check whether you are getting 12 volt. So 9.6 plus 2.4, that is 6 plus 4 is 10. 9 plus 1 10, 10 plus 2 12 volt. So the total voltage what we are connecting is 12 volt, that gets divided between these two capacitors connected in series, that is 2.4 volt and 9.6 volt. So that completes the problem. So first one is to find out the value of C, then the charge, then the potential drop across each capacitor.